Thank you for joining us this morning. My name is Tim Stewart. I'm from Visual Decisions. What we're here to discuss is moving beyond traditional OEE systems with I-IoT, or Industrial Internet of Things. So, first of all, why OEE and then why I-IoT? To answer that, OEE, for those of you that don't know, is a composite performance metric. It encompasses availability, which is whether the equipment is running or not running, the performance, which is the speed of the equipment. So if it's supposed to run 100 pieces per minute, is it actually running 100 pieces or is it running 90 pieces per minute when it's running? And then quality, which is just, am I producing parts correctly the first time? So this is important because if a machine has an OEE of 100%, that means that it's run 100% of the time that it's scheduled, has zero time lost for changeovers, breakdowns, short stops, or anything else. It always runs at 100% of its rated speed, and it has zero defects. So good goal for machine performance. At a basic level, what this is trying to do is to take a machine that is not performing well, has a lot of variation to it, and change that so that not only is it performing better, but has much less variation to its performance as well. So the reason that this is important is that those machines, if they're running more effectively, have a lot of impact on the business. So just thinking that through, if you're in a position as a business where if you can make more, you can sell more, then obviously you're going to increase sales by increasing the output of the factory. If you're running things more effectively, you can reduce your material costs because you're reducing your waste. You can potentially reduce your direct labor. You can reduce your outsourcing if you have material that you're having a subcontractor build for you. Your indirect labor, your indirect materials can go down. Your logistics costs, expediting and so forth, maintenance, warranty, utilities, all of them can be impacted if you're running your equipment more effectively and more predictably. In addition to that, you can also reduce your inventory and you can spend less on your plant property and equipment. So OEE is very important. So why I-IoT? Well, Industry 4.0, this is from McKinsey, talking about the impact that Industry 4.0 and I-IoT can have across all of the different areas of operations. And as you can see, not only just on the shop floor, but really across all of operations, IoT and Industry 4.0 can have really huge benefits in productivity increases, reduction in maintenance costs, reduction in time to market, etc. So just taking another look at that from one of the platform vendors, PTC, work with PTC ThingWorx quite a bit, and looking at what they present as some of the primary use cases in manufacturing for smart connected operations or IoT. You have applications in manufacturing engineering, in production execution, supply chain logistics, maintenance, EHS, quality, and then operations management. And right there in that corner is where OEE resides. So not only are you getting the benefits of the OEE with I-IoT, but instead of putting an isolated data island, isolated system in place, you're actually putting in a platform that can touch all of these different areas. So how do you create that complete profile? Well, first of all, every single step in the value chain creates data. And so this is looking at a bakery, but you have receiving an inspection all the way through the build process, and then packaging and shipping. You're generating data at every step along the way. And so how do you then take advantage of that data? How do you use that data effectively to improve the operations? Well, So you have metrics such as OEE itself. And those performance metrics are great. They give you a scorecard or a report card of how you're performing. Are you winning or losing? You know, how are you doing as a business? But what they don't do is actually help you improve things. So if you think about it, if I know that my OEE is 50% and my target is 70%, I know I'm not doing what I want to. I know that I'm not performing as well as I should, but I don't know why, really. So what the diagnostic metrics help you do is to actually diagnose the problem and figure out where the inefficiencies are occurring in the shop floor and really tie that into what can be done about it. So just as an example here, if we look at quality metrics, and we might look at something like first pass yield. And first pass yield might be impacted by cracking defects. And those cracking defects could have a whole variety of different categories within them. Maybe it's arc strike cracking, cold cracking, crater cracking, hot cracking, etc. And then each one of those could go into different details of what's causing that. And then you have different corrective actions for each one of those different types of failure. And so by understanding that detail of what those errors are, now I can actually start to take the correct actions to address those defects. So the way that this kind of rolls up is that you have those diagnostic metrics with the truly detailed information that rolls up into those performance metrics, including OEE, and then those roll up into the financial metrics that we talked about a few slides ago. So just going through more details of a customer example here, and I'll stick with the bakery that we talked about a second ago. We created an overview slide for them, our overview application for them that showed them what their performance looked like. And we were able to do a lot of things in here. So we saw lost time, we saw material waste, and we could trend that out over time. We could see where they had fluctuations, how much they were losing on a kind of a steady state basis, where they had spikes. Then we were able to do things like compare day over day performance, week over week performance, month over month performance. Are we getting better or worse? And we could see that in either dollars or pounds and minutes for material waste and lost time. And that was very good. It really helps for some of the changeover meetings and so forth, or some of the big boards, and having conversations around what the performance looked like for that current day, for the week and so forth. But it again was at that top level. So what we did was we then provided a drill down. So for every time that the line stopped, we actually had the operators tag, why did it stop? And we looked at what area was it? Was it an equipment loss, production loss, quality loss, etc.? And then within each one of those areas, we looked at a category and a cause within there. And if we drill down on these, we can start to look at the oven. Equipment loss was a major area of loss, and then the oven was the single biggest area within there. And then if we look at the cause, it was other, but they were putting in reasons. And what we could see was that we were losing massive amounts of time due to these oven shelves flipping due to broken pins. And what we saw here is that on a normal basis, we didn't lose much time each day to the oven failing. But when we had a failure, it brought us down for a very long time. And what we've identified was that these oven shelves and the broken pins were the big issue. So what we were able to do is to identify a different type of pin that didn't fatigue as much going through the oven. We changed the cycle for preventive maintenance on those pins and so forth. And we were able to completely eliminate the single biggest source of loss within the factory pretty easily once we understood. For other types of loss that we would drill down on, we would see that there weren't these big spikes. It was just a consistent amount of loss across the board. And those were things like conveyor jams and jams within equipment and things like that. And for those instead of being a preventive maintenance issue, those were much more poka-yoke or error proofing types of things that we had to take a look at. And so once again, understanding where those were occurring and what the cause was allowed us to take the corrective action for those as well. And in the end, we were able to drive the OEE up by over 25% within a very short period of time. So in addition to OEE, there's more to the shop floor than just OEE. So it's an overall, very broad metric and so forth, but there are additional metrics on the shop floor and additional processes on the shop floor that you should be looking at. And so the metrics that you collect should really align to the processes. And so if you're doing Six Sigma, there's information that you want to be collecting there. You want to be running your statistical process control, SPC. There's things that you want to be doing in total quality management, in TPM, et cetera. And so instead of just focusing on OEE, it's good if you're implementing one of these systems on the shop floor anyway, you should put one in place that does more than just focus on one small branch of the overall operational excellence picture. So one of the things that we've done with customers is to automate SQDCIME, which is safety, quality, delivery, cost, inventory, manpower, and environmental. And there are metrics for the shop floor in each one of these different areas. And if you think about it, you've got those metrics at an operational level, on a machine by machine basis. Then that kind of rolls up into a cell or a department, and then up to a plant, and then within a division, and then the overall corporate. And the most important people to see these metrics are actually the people on the shop floor. They're the ones that have direct ability to influence what those are. And so how do you set this up so that they can see what they're doing, but then that same data automatically aggregates to those additional levels? So the traditional way of doing this is through a system called Excel. And you type all of this stuff in, and then the next level up from you takes spreadsheets from different groups and types those in, and then the level above them takes spreadsheets from different groups and types that stuff in. And what you end up with is a lot of waste in the system, and a very slowly updating process as well. So we've worked with a couple of, actually 3 different companies and the COOs of those different companies to create a live system that takes the SQDCIME information from the shop floor and aggregates that up in real time. So in this particular case, blocked out the names of the plants so that we couldn't tell who it was. But, oh, I didn't do it over there. But anyways, we can see for any given time period, for any given metric, is that plant green or red? Are they winning or losing? And at an overview, you can see what the plant performance is like. And then here, what we can see is what was the actual value, what was the target, how bad was the miss, and then we can see the explanations for that. So once again, it's not just looking at the metric itself, that performance metric, but you want to be able to see the why. You want to understand what happened. And the other thing that we did here was tie it to the corrective actions and track those corrective actions within the same system. So this bubbles up all the way from the shop floor, all the way up through the Chief Operating Officer. So another thing that you want to be able to do is to tie this into the actual dollars. And so when you have a plant manager, they're looking at a daily report. They want to understand, are they on target or off target when it comes to costs? And if you think back to the 90s, people were doing or trying to do activity-based costing, and that effort kind of stalled out because there just wasn't enough data. But if you're doing I-IoT and you're tracking the materials and you're tracking the labor and you're tracking the machines, you really have all of those dynamic elements within the process. And you can actually now cost all of those elements out and create a picture in real time of how is the factory performance, not just from operational metrics, but also from those financial perspectives as well. So a lot of what I've talked about so far, in fact, pretty much everything I've talked about so far, is all using input from the people. And being able to take that information, have the operators provide reasons for why machines are stopping, be able to analyze that information themselves and so forth. But in addition to that, we now have the capabilities with these IoT platforms and Industry 4.0 to incorporate machine learning. And as we're looking to incorporate machine learning, we started off talking about these descriptive metrics and the diagnostic metrics, but now I want to talk about predictive and prescriptive metrics as well. And so predictive is asking the question, what will happen? And prescriptive is all about what should I do? And as an example here, we worked with a firearms manufacturer, and they had a plant where they were making bullets. And for each of those rounds, when they were starting to do a new one and set up a machine to run a particular type of round, they would run a set of 100, and then they would send that off-site in order to be tested, because you can't actually fire bullets where you have gunpowder in the air. And so, excuse me, they would send that off to the off-site range. They would fire those. They would look at the pressure, accuracy, and velocity for those. They would put that into a spreadsheet and they would send it to engineering. When the engineer got back to their desk, they would open that up and they would look at those test results. And based on prior experience and set of rules, they would then recommend adjustments to the loading process, number of grains of gunpowder, etc. And they would put that in the spreadsheet, and then they would send that to the supervisor. Well, the next time that the supervisor went to their desk from the shop floor, they would then get the spreadsheet, and then they would go and make those adjustments to the loading. Well, that process could take 8 hours. It could take another shift. It could go over the weekend. And by then, of course, the humidity has changed. And as you can imagine, gunpowder is very sensitive to the humidity level. And now you would have to run another sample, send that back to the range, and go through that whole process again. And that could take days. That the machine would be down waiting for the quality to be right on the range. What we were able to do is to still build that sample of 100 pieces, send it out to the range, but now the range would enter that information directly into a database. That database, once that information was entered in, we put that into this decision-making process, and we fed that directly back into the loader, running through that same set of rules that the engineers would run through, but we automatically adjusted the loader to account for what changes needed to be made, and then we could just run right away, because that whole process now took 15 to 20 minutes. And so we were able to dramatically increase the performance of that plant simply by automating that loop and looking at these prescriptive analytics. So sticking with the predictive for now, we start off with data. We run that through some set of logic, and there's a lot of different algorithms that can be used for analyzing that data and so forth. And from that, we're trying to gain some sort of insight. And then over time, we look at the accuracy of those insights. We feed that back into the model, and we improve the performance of the model over time based on how accurate those predictions are. And so it's a closed loop process that we iterate upon to make things better and better. But what we're trying to do is just to determine in the current performance, what can we predict based on the data that we're collecting? So from that basic process, there are a number of different ways to use that capability on the shop floor. Now, OEE systems, and I've worked with a lot of them, will tend to focus on this first one here, predictive maintenance. And they do it reasonably well because they're looking at the tags or the process variables coming from the machine, the PLC, and they're able to collect that information and run predictions based on what's going on there. What they lack, though, is any external information about that machine. And so a lot of those systems don't understand what part is running. And the performance of a machine can vary quite a bit based on that. So for example, we're working with a machine that uses a lot of grinding equipment on metal. And the hardness of the part certainly has a big impact on how long the tooling is going to last, when the machine itself needs maintenance and so forth. And so external systems can provide context that the algorithms can use if they have that information available. Last time the predictive or preventive maintenance tasks were done, how old is the oil in the machine, et cetera. And if you don't have those connections into external systems, your predictive capabilities are going to be lessened as a result of that because you simply don't have the context. But an I-IoT system has those links to other systems and has that broader capability to not only improve the performance on those predictive maintenance aspects, but then also do predictive capabilities in all of these other areas. And that contextualization of the data is very important. So instead of having a simple isolated system that's going to sit and be completely separate from an SPC system, that's completely separate from your external warranty system, that's completely separate from this and so forth, you can pull all of that information together and have a system that acts as a data hub for the entire shop floor. It's also very important because when you're analyzing these problems, you want to be able to kind of automatically identify, classify, and prioritize what's happening. So there's two basic types of OEE systems that are out there standalone in the marketplace. And one of them is really centered on the machine learning aspects of things and really looks at just that PLC data that's coming in and makes its predictions based upon that. And we'll show you machine status of running, not running, and how much downtime you've had, and does a reasonably good job of all that. Again, there are areas where it could improve, but the things that those systems typically don't have is any context coming in from the people in the system. So they don't understand anything beyond e-stop. So if you have a machine that gets an e-stop, they don't understand what really drove that. And so they're limited in terms of what types of downtime you can address using those systems. If it's something that the PLC knows about, they're great. If it's something that the PLC doesn't know about, then not so much. Now, the other type of system is much more old school type of OEE system that the machine goes down, you have the operator input, what happened and why, and then you move on. And they're not typically tied to the PLC reason codes and everything else. And so you don't get that machine information. They typically don't have the machine learning because they don't have the level of detail or granularity of the data that they need to run that side of things. But they do a good job of collecting that information at a high level and pointing continuous improvement process into those different areas. But they're both isolated data islands. And so what we want to do with an I-IoT system is to eliminate all of those different problems. So by building an OEE system on top of this platform, what we can do is we can break those data islands, we can contextualize the information, and then we can automatically identify issues where we can from the PLC. We can also take in information from the people involved in the process and incorporate that within there. And we can classify and prioritize these issues automatically and take a lot of the burden off of the user for doing that themselves and doing data discovery. So along those lines, I wanted to talk about some of the analytics and some of the different workflows that we've built up for our customers as well. So there's really two types of different analytics that are involved in these systems, discovery analytics and guided analysis. And the discovery analytics are basically, I have a whole set of reports and I can slice and dice that data in a large number of different ways. I can look at trends, I can look at Pareto charts, pivot tables, and other views of the data that really let me figure out, where should we be paying attention? What are the big problems? Where do I have the most downtime? What are the different causes for that downtime and so forth? And it is incumbent upon me as a user to really explore the data and figure those things out. The different type of analysis is guided analysis. And with that, what we're trying to do is provide structure around a single topic and just picking one, looking at setup analysis. And if you're an engineer and you're trying to do setup analysis, what are the different things that you want to look at within the process? How much variation do we have in each step of the process? Are all of those processes required? How many people are involved in each step and so forth? And by collecting that information and having the flexibility within an IoT platform to collect that type of data, we have the ability to lead the user through a workflow of that analysis and really guide them through that process, rather than making it incumbent upon them to just explore the data and figure those things out themselves. So some examples of guided analysis that we've provided to different customers. Looking at real-time value stream map, where you have a work order that you're tracking, you can actually map that whole process out automatically. I'll talk about that one on another slide. Looking at setup analysis and looking at that sequence dependence view, how much setup variance do you have that exists and what are the causes for that? Being able to do a full SMET analysis and so forth, and actually leading the user through that process. If you're looking at tooling, what is the defect rate versus tool life? How do I plot that out in such a way that I can actually show where I should be changing tooling and so forth? If I look at my cost of tooling versus the impact on quality and downtime, and helping the user balance those things off so that they can make those decisions intelligently as well. And then looking at different suppliers for that tooling and what impact does that make on the process. Looking at production schedule, so being able to do schedule adherence, on-time performance, schedule versus production, and so forth. And being able to look at how well the plant is actually performing versus that production schedule, but also how is that production schedule impacting the plant? Where do I have operations that are starved? Where do I have operations that are blocked, and so forth? Preventive maintenance. Am I doing the right PMs? Am I doing a PM often enough? Am I doing it too often? Those are things that have a workflow to those decisions in that analysis. But OEE systems don't provide that kind of information, even though they have data that applies to that. But again, because they don't necessarily tie to your maintenance management system, they don't necessarily have the data of what are the structured PM activities. And they don't really know when PM activities are being run in a lot of cases, especially if it's the more automated machine learning type of OEE system. And so they just don't have that data. They don't have that connection, so they don't have that capability. But with that data hub, you can pull that information together and you can actually run that whole process. And then again, looking at the daily variable cost analysis, where are my variations versus standards and so forth. So looking at a real-time value stream map, if you think about what's in a value stream map, especially if we're just looking within the four walls, you're looking for what are the steps in my process, what is the amount of time that I spend in that process, and then how much time am I spending between steps in that process. So where do I have value add time, where do I have non-value add time? And how can I eliminate as much of the non-value-added time as possible so that I can compress the lead time that I have for my goods. And if you think about the different systems that you're putting in place, an OEE system actually comes pretty close to having this data, but you can get all of it with an I-IoT system. And especially if you're tracking work order numbers as well as part numbers and so forth, you have the capability of looking even across sub-assemblies to parent assemblies and so forth that will allow you to say, for this given item, what are all the steps that I typically run in this process historically? And then for any given time through that process, I can look at how much time did I spend within each operation, how much time did I spend between them? And then I can graph that over time and say, what is my variability of time spent within and between? And now once I have that established, I can use that in my planning systems. I can also use that for improvement activities instead of just creating a value stream map by a bunch of people sitting in a conference room and saying, I think it takes about 2 days between those steps. Now you can have something that's live and you can actually measure the current performance of a work order on the shop floor against that as a standard. And I can start to alert based on when things are taking longer than they should and so forth. So there's tremendous capabilities that you have by expanding the view of what these systems should do. Another one is an FMEA, failure modes and effects analysis. These have been around since the 40s, I think, and tremendously useful tools for analyzing either product or process failures. But how they're generated very often is you get a cross-functional team together in a conference room and you brainstorm different potential failure modes. What are the effects of those? How severe is it? What are the potential causes? How frequently does it occur? How likely are you to detect it? And from all of that, you create your RPN. And what are your recommended actions when that actually occurs? So if you think about this, what we talked about earlier is, as we're collecting information from the machines, whether it's from the PLC directly or whether it's from an operator, pressing a button for what type of failure occurred, what we're trying to build up over time is that Pareto of issues, kind of a root cause diagram of, what were the sources of the problems, and then, what were the different causes within there. Well, that ties directly to the FMEA. That's exactly what the FMEA is trying to identify, are all those different failure modes and how frequently they occur and so forth. So why is it that I've never once walked into a manufacturing company that was doing anything along the lines of OEE, collecting downtime reasons, et cetera, where those reason codes that were identified within here were actually tied to the FMEA that had been done in the process? And if you think about it, they should absolutely be tied together. And the information that you're collecting from the data collection process can be used to create a live FMEA that is looking at what is my probability of occurrence, what is the severity of that. I may need to, put additions to that data for, downstream impacts and so forth that the system can't see, safety violations, et cetera. But that severity code, I have quite a bit of that just from the downtime information of the process itself and so forth. And so being able to tie these things together and incorporate that into the process and have the FMEA as another view of this data and so forth is tremendously beneficial to the company and increases the value of the FMEA and increases the value of the OEE/IoT system. So in summary, OEE itself is a very good composite metric, but OEE systems tend to be isolated data islands with somewhat limited functionality as a result of that. IoT platforms can provide all of that OEE functionality, but much more as well. And we at Visual Decisions, we've worked with our customers to create factory systems that act as that data hub for all the shop floor information. serve as a basis for the management operating system, the SQDCIME process that looked at that information from the COO all the way down through the shop floor, or more accurately from the shop floor all the way up to the COO. That augment that human intelligence with the machine learning and don't focus overly heavily on one or the other. And then also provide workflows and guided analysis that really are biased towards taking action. So as I work through those workflows, it should actually lead me to take steps that actually modify the process. And obviously the reason for doing that is, I use the example of a Fitbit all the time. I've worn a Fitbit for 7 years now, and I've gained weight during that time. It's not that the Fitbit is broken, it's that I haven't changed my behaviors. And until you change the behaviors of the people on the shop floor, none of these systems will actually drive the benefit that you're looking for. So being able to provide those workflows, that guided analysis, that bias towards action is critical to getting the value that you're looking for. So thank you very much. If you have questions, you can put them into the chat or the Q&A. And we do have one question here. Will I be sharing the presentation? The answer is yes. If you want the presentation, send me an email at tim@visualdecisions.com, and I'll be plenty happy to share the presentation and hopefully strike up a conversation with you about how you're doing this within your own business. Any other questions? Well, thank you very much for your time this morning. And again, if you want more information, please follow up with me either at my email or my phone number, and I'll be plenty happy to talk. Thank you very much.